Point R divides the line segment PQ in the ratio m is to n. Then OR is the position vector of the point R here. Then the position vector R is given by m into vector B plus n into vector A divided by m plus n. The magnitude of AB, magnitude of BC and magnitude of AC in such a way that they should satisfy the condition of Pythagoras formula, that is A square is equal to B square plus C square. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So in this session, we are going to study about the section formula under vector algebra. So here, if a point R divides the line segment joining two points P and Q internally in the ratio m is to n, then the position vector of R is given by R is equal to m into vector B plus n into vector A divided by m plus n. Now, consider the line segment PQ. Let vector A be the position vector of point P and let vector B be the position vector of point Q. Let O be the origin with respect to the coordinate axis. Now let point R divides the line segment PQ in the ratio m is to n. Then OR is the position vector of the point R here. So from the figure, we can write here PR divided by RQ is equal to m by n. So this is OR minus OP divided by OQ minus OR. So using the position vectors of vector PR and vector RQ. So this is equal to m by n. So we will get this as vector R minus vector A divided by vector B minus vector R. Because here we can clearly see OQ is B, OP is A and OR is A. Now this is equal to m by n. Now when we cross multiply this is actually n into vector R minus n into vector A divided by m into vector B minus m into vector R. Now let us shift mr here, then it is m into vector R plus n into vector R is equal to m into vector B plus n into vector A. If we take R as a common factor, we will get the values of m plus n here. Then it is m into vector B, n into vector A. Then the position vector R is given by m into vector B plus n into vector A divided by m plus n. So this is the position vector of the point R which divides the line segment PQ in the ratio m is to n internally. Next, the same external condition if we take, so let us take PQ is the line and let R be the point which divides these line externally in the ratio m is to n. If we consider this, we can write this as PR, vector PR divided by QR. This is equal to m by n. Now this can be written as OR minus OP whole divided by OR minus OQ is equal to m by n. So if we cross multiply this, we will get this as R minus A divided by R minus B is equal to m by n. Now NR minus NA is equal to MR minus MB. So let us shift here, then this is MB minus NA is equal to MR minus NR. So here now m into vector B minus n into vector A is equal to m minus n into vector R. So if we need vector R here, then it is m into vector B minus n into vector A whole divided by m minus n. So this is the position vector of the point R which divides the line segment PQ externally in the ratio m is to n. Now here we have learnt that the position vector of point P is given by m into vector B plus n into vector A divided by m plus n internally. That means m is to n. So it's the ratio of the line segment. Now suppose if m and n are equal, that is 1 is to 1. That means R will become, that is the point R is the midpoint of the line segment PQ. So then the ratio m is to n will become 1, 1. So if you substitute the value of m and n as 1 in the given formula, then m, it is the midpoint formula. So therefore any point R or any point m will form as a midpoint of a line AB. So here R is the midpoint of line PQ. Similarly, we can consider any line AB where m is the midpoint of AB. Then OM, that is the position vector of point M, vector R is given by A plus B divided by 2. The next thing is, if A, B, C are collinear in which B divides AC, that means suppose we have a line AC and B is a point on the line AC, then clearly from this figure we can say A, B, C are collinear. Now with the help of vectors we can say that is the magnitude of AB, that is the length of AB plus length of BC should be equal to the length of AC. So if we prove this result with the help of the vectors, then we can say vector AB plus vector BC is equal to vector AC. Then we can say A comma B and C are collinear. Next, find the position vector of a point R which divides the line joining point P and Q, whose position vectors are I plus 2j minus k and minus I plus j plus k respectively in the ratio 2 is to 1 internally and externally. For an internally, we know the formula vector R is equal to m into vector B plus n into vector A divided by m plus n. So m is 2 here and n is 1 here. So vector B is minus I plus j plus k and vector A is I plus 2j minus k. Now let us use this formula and substitute. So m into vector B means we need to multiply 2 here. So minus 2i plus 2j plus 2k plus n into vector A, that is 1 into vector A, I plus 2j minus k whole divided by m plus n, that is 2 plus 1. So the value here is minus 2i plus I is minus I plus 2j 4j 2k minus k whole divided by 3. So this is the position vector of point R. Now if we consider the external condition, here we have vector R is equal to mb minus na divided by m minus n. So that means mb is minus 2i plus 2j plus 2k minus of vector A. So minus of vector A means it is minus I minus 2j. So minus of minus k becomes plus k whole divided by 2 minus 1, which is 1. So it is minus 2i minus I minus 3i plus 2j minus 2j get cancels. 2k plus k becomes plus 3k. So this is the position vector of the point R which divides the line segment PQ externally. Next question. If vector AB is equal to 2i minus j plus k and OB is equal to 3i minus 4j plus 4k, find the position vector of OA. So we know that vector AB can be written as vector OB minus vector OA. So using the position vector of vector A and vector B. So we have vector AB as 2i minus j plus k. Clearly they have given vector OB, that is 3i minus 4j plus 4k. So now I need OA here, vector OA. So let me shift OA here and vector AB towards the right hand side. Then it is OA is equal to 3i minus 4j plus 4k minus of this vector. So it is minus 2i minus of minus j is plus j minus of plus k is minus k. So now vector OA is equal to 3i minus 2i I. Minus 4j plus j is minus 3j. 4k minus k is plus 3k. So this is the position vector of point A. Next question. Show that the points A, B, C are the vertices of right angle triangle. So the position vectors of point A, point B, point C are given in the vector form. So if they forms the right angle triangle, then it should satisfy the condition of Pythagoras theorem. So that is the magnitude of AB, magnitude of BC and magnitude of AC in such a way that they should satisfy the condition of Pythagoras formula, that is A square is equal to B square plus C square, where A, B, C are the lengths of the sides of right angle triangle. Now let us consider AB. So vector AB is nothing but vector OB minus vector OA. So we need to subtract B minus A. I minus 2I is minus I. Minus 3 minus of minus 1 becomes plus. So minus 3 plus 1 is 2j. Next minus 5 minus k is minus 6k. Next similarly, let us consider the side BC. BC is OC minus OB. So that is C minus B. 3i minus I is 2i. Minus 4 minus of minus 3 means plus 3. So minus 4 plus 3 is minus j. Next minus 4 plus 5 is plus k. So this is the position vector of BC. Next the last position vector of AC. AC can be written as vector OC minus vector OA. So that is 3 minus 2i minus 4 plus j minus 3j minus 4 minus k minus 5k. Now since we need the length in terms of square, so let us find the magnitude of all vector AB, vector BC, vector AC. Now if we need magnitude of vector AB, it is square root of the sum of the squares of respective components. So let us take magnitude whole square since we need the square of the length. So it is minus 1 whole square plus 2 square plus minus 6 whole square. So which is 1 plus 4, 5, 36. So it is 41. Next we will calculate magnitude of vector BC whole square. So it is 2 square plus minus 1 whole square plus 1 square. So 4, 5, 6. The last one we have AC square. So it is 1 square plus minus 3 whole square plus minus 5 whole square. So it is minus 5 whole square, 25. So 25 plus 9, which is 34. 34 plus 1, 35. So now we can clearly see if you add AC square plus BC square, 35 plus 6, that is equal to 41 AB square. So clearly BC square plus AC square is equal to AB square. So therefore A, B and C forms the vertices of right angle triangle. So these are all one of the applications of the vectors where we can prove or verify whether the vertices form a right angle triangle, equilateral triangle, isosceles triangle. So today we have discussed some of the applications of the vectors. We'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.